Okay, so problem 3.32 says find voltage Vx for part A, and then it says to replace the source with just the general Vs, and then we want to find Vx as a function of Vs. So let's go ahead and do the first part, and I'm gonna use a universal method on this part. I'm gonna label this as ground. I'm gonna call this 45 volts V1 and then V2. So, and then we have currents. So we have the current IS going into the node, and then we have two currents coming out. I'm gonna say KCL IS equals I1 plus I2. And then our equation for components, we have two equations for I1, which the first one is 45 minus V1 over 5,000, which is also equal to V1 over 20,000. And then I2 is equal to 45 minus V2, 60,000. And then that's V2 over 90,000. And yeah, so we can also make an extra equation. You can say Vx is equal to V1 minus V2. Okay, so yeah. And then our missing variables are IS, I1, I2, V1, V2, and then Vx. So we have 6 equations and 6 missing variables. So let's go ahead and plug that into Maxima. Let's make this smaller. 6. Oops. There. So IS equals I1 plus I2. I1 equals 45 minus V1 over 5,000. I1 is also equal to V1 over 20,000. And 2 equals to 45 minus 2 minus V2 over 60,000. I2 is also equal to V2 over 90,000. And then we have Vx equals V1 minus V2. So our variables are IS, I1, I2, V1, V2, Vx. Cool. So we can go ahead and say Vx is 9, right? We can clearly see V1 is 36 minus 27, 9. So let's go ahead and call this, say Vx is equal to 9 volts, 36 minus 27, 9 volts. Vx. Right, so now we got the second part where we replace this 45 volt source with just whatever, with a variable, which could represent any random source. So yeah, so let's go ahead and redraw this circuit. So I'm gonna say Vs, so Vs, V1, V2, and then our ground. Right, and then I forgot to label what's 5K, 60K, 90K, and then 20K. So yeah, let's go ahead and do that. So same here. KCL stays the same. Call this I1 coming out and I2 coming out this node. All right, so we have our KCL. IS equals I1 plus I2, our EFC, which is I1 equals VS minus V1 over 5,000, which is also equal to V1 over 20,000. Then I2 equals to VS minus V2 over 60,000. And I2 is also equal to V2 minus 0 over 90,000. And our missing variables are IS, I1, I2, V1, V2, and then Vx. So let's oh yeah, and I forgot to include the equation for Vx. So Vx is V1 minus V2 again. So yeah, so let's plug this into Maxima. Okay. Oops. So 6 equations, yeah. All right. So then we see that dx is a function of ds over 5. Right. So dx is equal to ds over 5. And that would be our answer.